So always note when you look at one of these, when you look at a graph, what it is that they're asking you about, well, what the vertical is. Because sometimes it's position, sometimes it's velocity, and it makes a huge difference which one it is. And then I like to start at the beginning. I like to look here and just ask myself in my head, like picturing, what is this object doing at the moment I first encounter it? And in this case, let's see, it is moving or stationary. Well, let's see, if it was stationary, it would be 0, right? So it is moving. All right, is it moving in the positive direction or the negative direction? Well, since it's up here in the positive, it's moving in the positive direction. So this is an object, I can picture it in my head, that might be, if I assume that this way is positive, that when I first see it, has a velocity that is positive and in that direction. Now, as time goes on, what happens to that velocity? It decreases. And it decreases by the same amount each second. So it is slowing down. It is approaching 0 meters per second, which is anywhere on this line is 0 meters per second. So it slows down. If it has a positive velocity and it's slowing down, so one of the things that it's crucial that we understand is what it means to slow down and what it means to speed up. So when we slow down, our velocity is in one direction and our acceleration vector is in the other direction. So that's slowing down. Now in this case, positive velocity, negative acceleration. But I would just like to point out that you could also, in a different problem without this graph, you may have something, here I'll even find an empty space, you may have an object that is moving in the negative direction. In order to slow that object down, its acceleration vector has to be positive. It's when they work against each other that we have a slowing down. All right? It's not if acceleration is negative. It's possible, for example, if I drop an object, its velocity we would say is negative, but so is its acceleration. It's negative as well, and therefore when you drop an object, it speeds up. So when they're in the same direction, speeding up. When they're in the opposite direction, slowing down. So here it's got a positive velocity and the slope is negative. So one of the key things that this problem is trying to address is that you recognize that the acceleration, the change in speed, is the slope of a velocity versus time graph. So acceleration is the slope of velocity versus time. So this graph over here should represent the slope of every segment. So, for example, the slope of a horizontal line is always 0. So, this person, when they did this, they got that part right. Here it's 0, and here the acceleration is 0. Now, don't be fooled. It's not 0 here because it was 0 here. It's because it wasn't changing. It is 0, but the key is it doesn't change here. Here it might be 20 meters per second, but it's always 20 meters per second. So there is no change in velocity, so that's why the acceleration is 0 here. So they got that right. Check. Check. I'm good with that. Is this acceleration, is this slope positive or negative? Well, the trick with slope is as you move left to right, like we read, if the line's dropping down, it's a negative slope. So this is a negative slope, and negative acceleration, I like the fact that their acceleration here is negative. This goofy little line here is really a non-real thing. Speed can't change from moving to stopped in instantaneous. There will always be some sort of a curve or something. So this is just, I wouldn't worry too much about this. This is just that point. This is the corner right here, shows up as an almost vertical line. Don't worry about it. Then it's stopped. But the key is, it's not that it stops so much as its velocity doesn't change. So it has no acceleration, which is change in velocity. Then, what is its acceleration in this segment?
Did it go up or did it go
Alright, so the slope, if the acceleration is the slope of this line is positive, isn't it? As I go left to right, it goes up. So this is a positive slope, and they sure enough have a positive value for that acceleration. So I'm okay with that too.
Because it's like broken into parts, right?
Exactly. And each segment here should correspond to a segment over here. So I got the first segment, constant, as a decreasing acceleration, negative acceleration, I said decreasing acceleration, that would be wrong. Decreasing velocity at the same, that's a negative acceleration because the velocity was positive. Then we stay at a constant 0 meters per second, so this is 0 also. Then we have a positive acceleration. It is picking up speed. It's moving in the positive direction because it's up here, not down here. So its velocity is positive because it's up here. And its acceleration is positive because the slope is positive. And therefore, it goes faster, farther away from 0. And then when it goes at a constant velocity, there is no acceleration. It drops to 0 again. But I do see one problem with this, and it's a subtle one. Everything here looks pretty darn good. Slope, the size of the slope. The bigger the slope, the steeper the line. So this is a little slope. This is a big slope. They're both negative, right? But this is a little slope. That's a bigger one. Of these two, which is the bigger slope? The first one or the second one? The second one is definitely a steeper line. So, well, wait a second. If this one is that far, right? If this is the value of the negative one, what's wrong with this one? Yeah, it's not high enough. If this is, I would say it's high, so I put it up in here. So the only thing I can see wrong with this is that this value for the acceleration should be positive, but it should be bigger in magnitude. The number, like if this was 10, this should be like 12 to 14 maybe, or something like that, or 13 or 14, right? It should be bigger. It should not be small, because this is a steeper line.